What does the slope of a graph with units or a trend line really represent? Is it the change in units? Is it a quantity of itself? Well, that's what we're going to find out in today's video, where I'll be going over trend lines and slope. So, quick recap, right? The independent variable, or the x variable, goes in the x-axis. These are variables that you can change, okay? The cause that you control, like time or how much force you apply. The dependent variables are what you measure. You can't control them. For example, if you're in a car, you can control the time you drive, but then the distance the car covers is controlled by itself. It's a function of the time. You can't change it, right? So distance would be a dependent variable. And this one goes on the y-axis. If you're good with that, then let's look at a trend line. Okay? So y is equal to mx plus b is used for a trend line as well. Even though it's a bit different from a regular line, a trend line is the same quantity as a regular line. So it uses the same equation. M is the slope, b is the y-intercept, and the points are other data points. So like I said in my previous units, right? A trend line doesn't need to go through all the points or connect them. It needs to be an approximate best fit to the points. It could go through some points, but it should represent the position of the data set in general, where the data set is moving in general. That's what a trend line means, because it's just showing you the trend of the data, right? Where is it moving? It's not exact, but it's good enough. The slopes of trend lines, or the slopes of lines in general, have jobs. What kind of jobs? If you, for instance, take a graph with seconds, right? And then a graph with meters as its y unit and seconds as its x unit. So suppose this is time you travel, or the amount of time you travel. And then this is the distance through that time, okay? So then if you take the slope of a line that shows you your distance as a function of time, change in y over change in x, right? But then, so change in y will be some number, but what are the units of that number going to be? Well, 3 meters minus 2 meters, or any meter minus any meter, is still going to end up with meters, right? But what about seconds? Well, change in x, same thing. 3 seconds minus 2 seconds gives you seconds as the unit in the denominator. So now you can see that the slope of a trend line, or the slope of a regular line, represents quantities. So meters per second. If you remember, that's the quantity for velocity. So if you take the slope of a distance versus time graph, what are you going to get? You're going to get the velocity of that object. So then if you take the slope of another kind of graph, suppose you have time, and then you have velocity. So how fast you're traveling at each time, okay? So this should be measured in meter per second, velocity here. Suppose, obviously, I'll just draw a line. The slope, what would the slope of this line represent? Think about it for a second. So change in y would be in units of meters per second. So I'm going to write meter per second over change in x. Change in x would be in units of seconds, right? So it's going to be meter per second over second, or meter per second squared. So the slope of a velocity versus time graph gives you acceleration, the units of acceleration, right? Meter per second squared. And then as we move on in the course, you'll see instances where it's not just meters and seconds. It could be newtons and meters, or newtons and meters squared, or torque and meters, right? So these, it's important to know that the slope of a line represents a quantity. How fast the y quantity is changing per x, okay? It could give you its own quantity. So like I said, the slope of a distance versus time graph will give you the velocity of that object. Or the slope of a velocity versus time graph gives you acceleration. Okay? Its units tell you exactly what physics you're looking at. So let's just go over some quick practice now. I'll go over some more detailed practice when I push out my cumulative review for 1.1. Okay? But for right now, let's just go over some review questions to make sure that it's fresh in your mind. So first try them out on your own, and then I'll help you out with them. Okay. So in y is equal to mx plus b, we know this from algebra 1, right? M is just slope. B, y-intercept. A distance times slope gives what quantity? So, like I said, if distance was here in meters and time was here in seconds, time on the x, distance on the y, if you have a graph going like that, change in y would be represented in meters and change in x would be represented in seconds. So meter per second, or velocity. Now that's it's a bit different from speed. I'll explain why in the later kinematics units. But velocity, yeah. So this one is going to be velocity, not speed. But if you said speed, that's also pretty close. You're not wrong. It just sometimes you might be wrong. Which axis holds the dependent variable? Well, that's going to be the y-axis. Or if you use the acronym DRY-MITS, the dependent variable, dependent, is a responsive variable, which means it responds to the other one, and it's going to be on the y-axis. This one, manipulative variable, which means you can manipulate it, right? You can change it. Manipulative, and then I is independent on the x-axis. Okay. A steeper slope means a faster rate of change, or a rate of change with larger magnitude. Okay, so if you think about it, for the distance time graph I gave you as an example here, if the slope was steeper, that means the velocity was higher. If the slope was broader, that would mean the velocity was lower. If you want more detailed practice on this, like I said, I'll be pushing out the next video, right? So feel free to look at that. And that's it for today's session for Physics for Mods. Feel free to check out the other videos if you need help on anything else. And give me a like and subscribe if you can for more content.